All right, we have this Module 6 reality check assignment. Now this assignment is looking at a rocket launch. So just when we think about a rocket launch, kind of think about what's happening. If we drew a graph of it, if your time is on this axis and your height, we'll just call it h, is on this y-axis. So the rocket at time 0 is going to start at 0 height. It might come up a certain amount and then it's going to come down. And so that's what we're kind of looking at as we're learning how we can look at a quadratic function, basically something with x squared, and it comes down. Or sorry, how it can model how a rocket goes. This might look intimidating at first, but let's kind of look through it, and it's not as bad as it seems. It might seem at first. So g is the magnitude of the acceleration. V naught, that's how you say that, v sub 0 is the vertical component. H naught, or h sub 0, is the initial height, and the variable time is t. So this is kind of a general formula, but the one we're going to use for this equation is right here. Okay, so this is what we want to pay attention to, closely anyway. We have a rocket is launched from the ground. The height of the rocket becomes this. So notice h of t just means height. So whatever the height of the rocket is, you would put in right here. Now the height is based on how much time has passed, because like at time 0, the height is just going to be 0. But they might want to find out, okay, what about when 2 seconds have passed? Where are we going to be? Is it going to be in the middle? And so that's what we're kind of figuring out here. So the first question says, at what time or times will the rocket be exactly 32 feet off the ground? So if you remember, our h of t means height. So in this case, that would be our 32 feet. So basically it's saying, when is the height 32? So we're just going to put 32 in for h of t, put it equal to negative 16t squared plus 48t. If you hate the t's, go ahead and change them for x's. It will be just fine. Now when we're solving a quadratic function, we always want them in the form ax squared plus bx plus c equals 0, because we have a lot of ways we can solve them that way. So what we're going to do is we're going to subtract 32 from each side just to get it in that form. So those cancel. So I have 0 equals, I'm just going to put that on this side though. So the 0 equals negative 16t squared plus 48t minus 32 now equals 0. So to solve this, the first thing we're going to look at is greatest common factor. If you're not remembering how to do this, look in 6.1. So greatest common factor, we look, what's the biggest number I could factor out of each of these? Well, only 2 of them have t's, so I can't factor a t out, but I could factor a negative 16. I can see each of these 3 numbers are divisible by 16. So let's go ahead and factor negative 16. So then to factor, we just divide each. So negative 16t squared divided by negative 16, we're just left with t squared. Positive 48 divided by negative 16, we're going to have a negative 3t. And then negative 32 divided by negative 16, we'll just have plus 2. So it looks a lot nicer, right? Okay, last, we want to solve this now for 0. And so the best way to solve this is if we can factor it. So we're looking at for factors of positive 2 that add up to negative 3. Well, if we look at 2, the only possibilities are 2 and 1. They have to multiply to equal a positive 2, but since they have to add to equal a negative 3, that tells us they'll both be negative. So let's check that. Negative 2 times negative 1 would give us a positive 2. Now negative 2 plus negative 1 does give us a negative 3, so those will work. So we can still leave that negative 16 out front. We'll have t minus 2 then, and t minus 1. Okay, so when we're factoring, we just have to find the factors of this number that will add up to the middle number. Now if you want to check this, you can multiply this out, you can FOIL it out, and it should come out to be t squared minus 3t plus 2. Okay, last step, we need to set each of these equal to 0. Negative 16, we can just divide out. There's no t with it, and so it's just basically going to cancel out here. And then we're going to have, let me just give myself a little space here. We'll have t minus 2 equals 0. We solve that. So we get t equals 2. And then similarly, t minus 1 equals 0. Add 1 to both sides. So t will equal 1. So those are, this one actually has 2 different times where the rocket will be 32 feet off the ground. And if you think about that, that makes sense because the rocket has to go up and then down. So it's totally possible that it could be 32 at 2 different heights. So maybe we drew this wrong. So anyway, that can get you started. So again, remember the h of t stands for the height, and you can plug that in, the value, any value for the height, and solve for the remaining t values. If you're still feeling confused, please reach out. I'd love to help.